Alright, so in this video, we will discuss what a metric space is. Now, before we begin, I can't wrap my head around the fact that why do we call them space? Vector space, metric space. To make it simpler for myself and maybe for you, metric space is a set, vector space is a set. Okay, for now we will stick to metric space. So, what is metric space? Metric space is nothing but a set, say S, which satisfies certain properties. So it is nothing but a collection of objects. Okay, just a collection of objects such that they satisfy some property. This property in this particular set, in this particular case, is called a metric. Okay, and this particular property is actually a function. What sort of a function? A distance function. Okay, so any set S on which a distance function is defined, this set is called metric space. Okay, and the simplest, okay, wait. Now, the properties, there are three properties. Okay, first is that this distance between any arbitrary x and y belonging to the set which we are talking about. Okay, any arbitrary x and y belonging to S, the distance between them, or not necessarily the distance, and we will do an example of that as well. Okay, this is a certain function that is related to the distance. Could be distance, could be something else related to distance, and we will do an example to make it clearer. Okay, so what the first property for this metric is that any xy belonging to S, for any xy belonging to S, this d of xy should be greater than 0. Okay. Now these are very small numbers, not necessarily, but yeah, actually, yeah, they are very small numbers. Okay, and just like we call infinitesimally small, and yeah, this dxy will be equal to 0 if and only if x is same as y. Okay, now the second one is, yeah, sort of commutativity. Distance between x and y should be the same as distance between, not distance, the value of this function should be the same as the value of this function. Okay, and the third property is that, what was the third property? Yeah, triangle inequality. Okay, let's say dxy should be less than or equal to some dxz plus dyz. I think this needs explanation. Okay, so let's say this is our set, which we'll call metric space. Okay, and say, let's mark the points. Let's say this is x, and this is y, and this is z. X, y, and z. right? Now what they're saying is that this should be less than or equal to the sum of this. It will be equal when these 3 points are collinear and z is between them. Yeah. See, if this is x, this is y, and here we have z, and this is the line joining them. Okay. In this case, they will be equal. Otherwise, they will satisfy this condition, which is the triangle inequality. Sum of two sides is always greater than or equal to the third side. Okay. Right? I think you would be extremely familiar with this, but okay, like if this is a line, this is a point P, and this is Q, this is R. Now let's say that QP length is S and QP length is S, and this length PR, that is key. Okay. To form a triangle, this point P, it has to shift above or below the line. Only then these lines would raise up and we'll get a triangle. So P should be here. Obviously, Q, P, R, these are bold. Okay. We represent points with like bold alphabets. Okay. Anyway, so obviously we can see that QP plus PR, like let's say this is P dash. Okay. So obviously QP is less than QP dash and RP is less than RP dash. Okay. So sum of any two sides will be greater than the third side. It holds true for any of the sides. Okay, this is triangle inequality. Very basic, right? And this is what the metric space is. A set with a distance function satisfying these three properties. That is what a metric space is. Okay. Yeah, I hope this is clear. Okay, yeah, example. So I can remember one example where u mu xy was something like distance xy over 1 plus dxy. Now, what dxy is basically it represents a distance on a real line. Okay, so if this is x and this is y, so the distance would be y minus x, absolute value, right? If it is two-dimensional space, what would be the distance between 2 points x and y? Did I do a mistake? Okay, yeah, I did. And that's not how I should explain it. See? You know this, right? Distance between x and y. If this point is x1, y1, but why is this? Okay, yeah, this was a confusing thing in the text. In texts, this point was x1, x2, and this point was y1, y2. So the distance xy, technically it would be this. But anyway, it is just the okay, I should not write this. Okay, it means the same, but let me just remove it. So the distance, it would be y coordinates. Sorry, the second y coordinate is x2. Y coordinates squared plus, oh man, my bad. Actually, there is so much noise outside. I'm not sure if I would be able to post this video with a clean sound. But anyway, if it is manageable, I will just post it. So, yeah, in our real line, this is the metric dxy. Okay, in R2, this will be the metric distance function. Metric is just the distance function, a function that gives the distance between two given points in a set. Okay, now let's say we have a set S, and this is the metric function that we define. So let's see, does this matrix function, it satisfies three conditions? Does it satisfy that? Let's see that. So the first condition is this should be greater than 0. Okay, what do you think? This is distance, it is always positive for any real number. Oh, sorry, for any point on the real line. Distance between 2 points is always positive. So these two, this will be positive. So this entire quantity mu of x comma y would be greater than 0, right? Now, will it be 0 if it is the same point? Well, yeah, the numerator will become 0. So the entire quantity will become 0. Okay, so it will be 0 when we take the distance between the point and itself, or when x is equal to y, right? Now the second property, mu of xy should be equal to mu of yx. Well, fairly simple, because dxy is obviously equal to dyx. It is just the distance between 2 points. Okay, so doesn't matter whether you take it this way or that way. And the distance between 2 points will be the same. It is the absolute value of the distance, right? So 1 plus d of xy would be equal to 1 plus d of yx. Okay, yeah, and similarly, yeah, if you divide them, even then they would be equal, right? So this condition is also satisfied. Now the third condition, triangle inequality. Okay, this is a tricky one. Okay, we know that d of xy will definitely be less than equal to d of xz plus the distance between y and z. This we are sure of. Okay, now we have to put mu here. How do we do that? For mu we need, okay, let's try it. I can't remember, but yeah, let's give it a try. Mu of xy, it should be dxy over 1 plus dxy. This is our left hand side. And the right hand side is mu xz plus mu yz. Okay, what do we have here? D of xz over 1 plus d of xz plus d of yz over 1 plus d of yz. So let's take the LCM here, I think. Yeah, why not? Xz multiplied by 1 plus d of yz. Okay, I think I'll change the color. Okay, and in the numerator we'll get uh, d xz plus dxz dyz. Okay, it is getting messy. Just wait. So I'm just solving for the right hand side, okay? This. We are expanding this. So this thing multiplies by this thing, and I'm writing that. We'll get d of xz, d of yz, right? Plus now this thing will multiply with this thing. So we get d of yz plus d of xz, d of yz. Okay, nice. Let's see what do we get. Dxz, dyz plus d of yz plus these are the same quantities, right? Yeah. So twice of dxz dyz equals 1 plus dxz 1 plus dyz. These are positive quantities, right? None of them is negative. So I think we should include this also. D of xy on that side and 1 plus d of xy. I just wrote my left hand side, okay? And now since these quantities are positive, I'll just cross multiply, right? Let's see what we get. It is going to be lengthy. Xy plus d of xz dxy and then I have 1 plus d of yz, okay, which is less than equal to, and now I'll multiply this d of xz plus d of yz plus 2 times, okay, yeah, dxz dyz. This video will become painfully long. Dxy. Okay. I'll stop, I think. After this, d of yz plus 2 times d of xy, d of yz d of zx, and I'll stop here. You can see that this quantity and this quantity, it will be this quantity similar to this. Okay, so you can try and solve this, and you will see that the condition is satisfied. Okay, so it's not necessary that the metric or the distance function is actually the distance function. It can be a combination of distance functions. Okay, yeah. So again, metric space is a set. Don't get confused with space, because I got confused with the word space. Whenever we hear space, our tendency is to think about the physical space. It is not the case. Metric space is a collection of objects, numerical values in this case. Metric space is a set, okay, with a function, just like a group is a set with a binary operation. Metric space is a set with a distance function having three properties, and on the same lines, vector space is also a set satisfying those 8 or 9 properties of vector addition and scalar multiplication. Okay, so I think I would end the video